Hello and welcome. Tonight, we'll be exploring one of the most mysterious worlds in our solar system. A planet so familiar that at first glance, it almost seems like another version of Earth. For centuries, people looked up at Venus and saw a brilliant point of light, glowing softly before sunrise or after sunset. It inspired myths, guided travelers, and became a symbol of beauty across countless civilizations. Few could have imagined that beneath its luminous clouds lay a world hotter than an oven, where mountains shimmer beneath crushing pressure, and even the rain never reaches the ground. What makes Venus truly fascinating is not simply that it is hostile. It is that this extraordinary world began its journey alongside Earth. They were born from many of the same materials, formed in the same young solar system, and grew to almost the same size. Yet somewhere along the way, their stories quietly drifted apart until one became a thriving home for oceans and life, while the other transformed into one of the harshest places known to science. Tonight, rather than rushing from fact to fact, we'll gently follow that story. We'll explore what happened to Earth's closest planetary twin, why it changed so dramatically, and what scientists have learned from decades of patient observation and daring exploration. Along the way, we'll discover that Venus is more than a distant world. It is a natural experiment written across billions of years, quietly revealing how delicate the balance of a planet can truly be. So, find a comfortable place to rest, allow the day to slowly fade into the background, and let's gently begin our journey into one of the most fascinating stories in planetary science. Long before telescopes became powerful enough to reveal distant galaxies, before spacecraft crossed the emptiness between worlds, and even before people understood that planets were worlds of their own, there was one light in the sky that always seemed to invite curiosity. It appeared just before dawn, glowing gently against the fading darkness. At other times, it lingered after sunset, becoming the first bright object to greet the evening. To ancient observers, it was so brilliant that many believed it was two different celestial bodies, one belonging to the morning and another to the evening. Only much later did people realize they had been admiring the same neighboring planet all along. Today, we know that world as Venus. Even now, if you step outside on a clear morning or evening, Venus often catches your attention before anything else. After the moon, it is usually the brightest natural object in the night sky. It does not sparkle like the distant stars, nor does it wander unpredictably. Instead, it shines with a calm, steady brilliance, almost as though it were quietly inviting us to take a closer look. For thousands of years, that gentle light inspired stories. Different civilizations connected Venus with love, beauty, renewal, and hope. Its appearance marked changing seasons, guided travelers, and reminded generations of people that the heavens were filled with patterns waiting to be understood. There is a quiet irony hidden within that beautiful glow. The brightness of Venus does not come from glowing on its own. It comes from sunlight. High above the planet, an immense blanket of pale clouds reflects much of the sunlight that reaches it, sending that light back into space like an enormous mirror. From millions of kilometers away, those clouds appear smooth, peaceful, and almost elegant. Yet those same clouds concealed one of the solar system's greatest surprises. Unlike Earth's clouds, which occasionally open to reveal blue skies, oceans, and continents below, the clouds of Venus refuse to part. They form an almost continuous veil around the entire planet, hiding its surface so completely that, for centuries, no telescope on Earth could see what lay beneath them. That mystery encouraged the human imagination to wonder. If Earth possessed clouds, oceans, forests, and weather, perhaps Venus did as well. Since the two planets were remarkably similar in size, it seemed perfectly reasonable to imagine another Earth waiting behind those shining clouds. Some early scientists pictured warm tropical landscapes, others imagined endless swamps, gentle rain, or vast oceans stretching beneath the white atmosphere. A few even wondered whether strange forms of life might already be flourishing there. These ideas seem charming today, but they were not unreasonable. At the time, there was simply no way Venus and Earth appeared to be close relatives. Their diameters differ by only a small amount. Their masses are remarkable. For many years, scientists referred to Venus as Earth's twin. The name carried a quiet optimism. Twins often share similar beginnings. They may grow differently over time, but they start life with remarkable similarities. The same seemed true for these two neighboring worlds. And yet appearances can be wonderfully deceptive. As astronomical instruments improved during the 20th century, researchers began searching for clues hidden within the planet's atmosphere. Instead of finding evidence of oceans, they discovered an atmosphere unlike Earth's. Instead of signs of gentle weather, they found hints of extraordinary heat. The beautiful clouds that reflected so much sunlight turned out not to be made of water droplets at all, but of tiny droplets of sulfuric acid suspended high above the planet. Even then, the full truth remained hidden. The clouds continued to guard their secret until humanity finally developed the courage and technology to visit another planet directly. Spacecraft would eventually descend through that endless white veil, carrying instruments that could measure temperatures, pressures, and chemical compositions that no telescope could observe from afar. Their discoveries would overturn decades of hopeful imagination in only a few hours. The world beneath the clouds was not another Earth. It was something entirely different. Still, perhaps the greatest surprise was not simply that Venus was hostile. Space is filled with hostile places. Frozen moons drift through endless darkness. Giant planets churn with violent storms. Small rocky worlds are battered by radiation and meteorites. Venus was different because it looked so familiar before anyone truly understood it. It reminds us that two planets can begin with almost the same size, almost the same composition, and almost the same place within the solar system, yet spend billions of years following entirely different paths. One became a world where rivers carved valleys, forests spread across continents, and countless living creatures emerged beneath open skies. The other disappeared beneath an unbroken blanket of clouds, quietly transforming into a place that challenged nearly everything scientists thought they knew about rocky planets. In many ways, Venus is less like a distant stranger than a forgotten relative whose life took an unexpected turn. The closer we look, the more remarkable that divergence becomes. The bright point of light that has comforted skywatchers for thousands of years is not simply another planet decorating the heavens. It is a record of planetary history, preserving the story of how small differences, unfolding over unimaginable spans of time, can reshape an entire world. And before we can understand how such a dramatic transformation happened, we first need to leave the safety of distant observation and begin a slow descent through those silent clouds, where sunlight grows dimmer, the atmosphere becomes heavier, and one of the most extraordinary environments in our solar system gradually comes into view. Imagine, for a moment, that you are not looking at Venus from millions of kilometers away anymore. Instead, you are slowly drifting toward it. The brilliant white clouds that once appeared soft and peaceful begin to fill your view. From a distance, they seemed smooth, almost like delicate brushstrokes painted across the sky. Up close, they reveal themselves as an immense ocean suspended above an unseen world, stretching far beyond every horizon. As you begin your descent, sunlight gradually loses its familiar brightness. The clear blue light you know on Earth fades into a gentle golden glow. Layer by layer, the atmosphere grows thicker. The clouds become denser. The world outside feels quieter, as though every sound has been softened by an invisible curtain. There is no dramatic storm waiting to greet you, no towering waves, no roaring thunder. Instead, there is an almost unsettling calm. The deeper you travel, the less the sun resembles the brilliant star that lights our own world. Its light becomes increasingly muted, filtered through countless layers of cloud, until it resembles the soft illumination of an afternoon that never quite becomes evening. It is difficult to imagine that such peaceful surroundings could conceal one of the harshest environments anywhere in the solar system. Eventually, after passing through cloud after cloud, the surface finally begins to emerge. The landscape is unlike anything early astronomers once imagined. There are no forests, no oceans, no rivers reflecting the sky, only broad plains of rock, scattered mountains, ancient volcanic formations, and a horizon wrapped beneath a heavy orange atmosphere that seems almost too dense to move. Even the light feels different. On Earth, sunlight dances through the air with remarkable clarity. Shadows appear sharp, and distant landscapes often seem crisp after a rainfall. On Venus, the thick atmosphere scatters the remaining sunlight in every direction. Shadows soften, colors fade into warm shades of amber and copper. Everything appears wrapped in a permanent twilight, even though the sun is still shining high above the clouds. If you could stand there safely, the first sensation might not even be the heat. It would be the extraordinary weight of the air itself. On Earth, we rarely think about the atmosphere pressing gently against our bodies. It is something we have lived with since birth, so familiar that it becomes invisible to our minds. On Venus, the atmosphere refuses to be ignored. It presses downward with astonishing force. A helpful comparison is to imagine standing beneath nearly 1 kilometer of Earth's oceans. At that depth, the immense weight of the water presses from every direction. On Venus, there is no ocean above you. Instead, the atmosphere alone creates a pressure remarkably similar to that underwater environment. It is a strange idea to consider, air becoming so heavy that it behaves almost like a liquid. This enormous pressure would challenge not only living creatures, but also the strongest machines ever built. Every surface, every joint, every electronic component must endure an invisible force pushing continuously from all directions. For the spacecraft that eventually reached Venus, surviving the landing was only the beginning of the struggle. The environment never stopped testing them. Yet even this crushing atmosphere is only part of the story. The temperature beneath these clouds remains astonishingly high, rising above 460 degrees Celsius across almost the entire planet. That number is difficult to picture. Perhaps it is easier to imagine something more familiar. It is hot enough to soften or melt lead. It is hot enough to damage ordinary machinery within a remarkably short time. It is far hotter than the hottest deserts on Earth, hotter than the inside of most kitchen ovens, and warm enough that many materials we take for granted would quickly lose their strength. What makes this even more remarkable is that the temperature barely changes. On Earth, mornings feel different from afternoons. Deserts cool after sunset. Mountains offer relief from the heat below. Oceans help moderate coastal climates. Nearly every place experiences a rhythm of warming and cooling. Venus does not. Whether it is day or night, whether one region faces the sun or not, the surface remains surprisingly similar in temperature. It is almost as though the entire planet shares a single breath. There are no cool forests waiting beyond the horizon, no shaded valleys where the air becomes refreshing, no polar regions wrapped in ice, no quiet lakes that soften the heat. Every direction leads into the same immense environment, where warmth has become a permanent feature rather than a passing condition. This is one of the qualities that makes Venus feel so profoundly different from Earth. Our own planet is wonderfully varied. Every journey eventually leads somewhere new. Snow gives way to forests. Forests become grasslands. Grasslands meet coastlines. Even the sky changes from season to season, reminding us that Earth is constantly reshaping itself. Venus offers almost none of these gentle contrasts. Its atmosphere works tirelessly to spread heat across the globe, smoothing away many of the differences that we naturally expect between one place and another. In a curious way, the planet behaves almost like a single connected system, rather than a collection of separate climates. Even the weather carries an unfamiliar rhythm. High above the surface, the clouds are filled with tiny droplets of sulfuric acid rather than water. There, droplets slowly gather and begin falling, much like rain does on Earth. But the journey never reaches its destination. As the droplets descend into warmer layers of the atmosphere, they gradually disappear, returning to vapor long before they can touch the ground below. It is a remarkable cycle. Rain that never reaches the land. Clouds that endlessly create droplets, only to reclaim them again. One of the most familiar experiences on Earth becomes something entirely different on Venus. Our minds naturally associate rain with rivers, growing plants, and the comforting sound against a window. On Venus, rain belongs to an endless atmospheric cycle that never nourishes the landscape beneath it. Even beauty can become deceptive here. The bright clouds that make Venus so striking in our skies are the very same clouds that hide this extraordinary world from distant observers. Their brilliance reflects sunlight with remarkable efficiency, making the planet appear almost welcoming. Yet beneath that shining veil lies an environment where every element, heat, pressure, chemistry, and atmosphere, works together with quiet persistence. Nothing happens suddenly. Nothing announces itself with dramatic spectacle. Instead, the planet patiently maintains the same relentless conditions, day after day, year after year, for spans of time almost beyond imagination. And as remarkable as these conditions are, they still leave one important question unanswered. Venus is not the closest planet to the Sun. If another world receives even more sunlight, why did this one become the hottest place among all the planets that circle our star? The answer lies not only in the sunlight that reaches Venus, but in something far less visible: the extraordinary way its atmosphere learned to hold on to warmth and almost never let it escape. At first, the answer seems obvious. If someone asked you which planet should be the hottest in our solar system, most of us would probably give the same reply: Mercury. After all, Mercury circles closer to the Sun than any other planet. It receives far more sunlight than Venus, and every sunrise there begins beneath an enormous blazing star that dominates the sky. It feels like a simple question with a simple answer, and yet nature quietly tells a different story. The hottest planet is not Mercury, it is Venus. This surprising fact has puzzled people ever since scientists first measured the temperatures of both worlds. It almost feels like discovering that a house farther from a fireplace is somehow warmer than the one standing right beside it. The explanation begins with something we rarely notice on Earth, because it is always around us: the air. Imagine stepping outside on a cold winter evening. Now imagine wrapping yourself in a thick blanket. The blanket does not create warmth by itself. Instead, it slows the escape of the heat already leaving your body. You remain warmer because the heat stays close to you for longer. Earth's atmosphere behaves in much the same way. It is not simply empty space filled with invisible gases. It acts as a gentle insulating layer, allowing sunlight to warm the surface during the day, while helping some of that warmth remain through the night. Without this natural blanket, our planet would become dramatically colder after sunset, and life as we know it would be very different. Mercury, surprisingly, owns almost no blanket at all. Its atmosphere is so thin that scientists often describe it as being almost non-existent. There is very little surrounding the planet to hold on to warmth after the sunlight fades. As a result, Mercury experiences enormous swings in temperature. Its days become intensely hot beneath direct sunlight. Its nights become astonishingly cold once darkness arrives. It is rather like heating a metal pan on a stove. The moment you remove it from the flame, it begins cooling almost immediately, because nothing is helping the heat remain. Venus lives by entirely different rules. Instead of a thin atmosphere, it possesses one so massive that it surrounds the planet like an enormous invisible ocean. Layer upon layer of gas presses downward, forming a blanket far thicker than anything Earth has ever known. This blanket changes everything. Sunlight still travels through the upper atmosphere and reaches the surface below. Rocks absorb that energy just as they would on any other planet. Then something remarkable happens. The warm surface begins trying to release that heat back towards space. On Mercury, much of that warmth escapes freely. On Venus, the journey becomes far more difficult. Imagine sitting inside a parked car on a sunny afternoon. The sunlight passes easily through the windows, warming the seats, the steering wheel, and the dashboard. After a while, those surfaces begin releasing their heat back into the air inside the car. But much of that warmth becomes trapped. Even if the outside air feels pleasant, the inside of the vehicle grows steadily hotter because the heat cannot escape as easily as it entered. A greenhouse works in a similar way. Warmth slowly accumulates inside until the interior becomes much warmer than the surrounding environment. Scientists call this process the greenhouse effect. On Earth, it is not an enemy. In fact, it is one of the quiet reasons life exists at all. Without a natural greenhouse effect, much of our planet would remain frozen, and liquid water would become far less common across its surface. The greenhouse effect itself is not unusual. What matters is its strength. Venus possesses an atmosphere made almost entirely of carbon dioxide, a gas especially effective at holding warmth. Rather than allowing heat to drift easily back into space, this enormous atmosphere repeatedly absorbs and releases thermal energy, slowing its escape again and again. You might imagine countless invisible hands gently passing warmth from one layer of air to another, refusing to let it leave. Over immense stretches of time, the result is extraordinary. The entire planet grows warmer, then warmer still. Eventually, the surface settles into temperatures exceeding 460 degrees Celsius, making Venus even hotter than Mercury, despite receiving less sunlight from the sun itself. Perhaps even more surprising is what happens after that heat has accumulated. It refuses to stay in one place. On Earth, temperature differences create familiar climates. Tropical beaches feel different from snowy mountains. Day differs from night. Summer differs from winter. Our atmosphere is constantly redistributing warmth, yet many local differences remain. Venus smooths those differences away. Powerful winds high above the surface continuously transport heat around the globe. Combined with the immense thickness of the atmosphere, they help create a world where temperatures remain astonishingly similar almost everywhere. It is as though the entire planet shares one enormous reservoir of warmth. No corner escapes it. No valley quietly cools after sunset. Even though a single day on Venus lasts longer than its entire year, the atmosphere works so efficiently that the contrast between day and night becomes surprisingly small. For a long time, scientists wondered whether this strange balance could truly be possible. Today, spacecraft observations and computer models largely agree that the atmosphere itself performs the remarkable task of spreading warmth around the planet with extraordinary efficiency. The more researchers learned, the clearer one lesson became. Distance from the Sun is only one chapter in the story of planetary climate. A planet's atmosphere can matter just as much, sometimes even more. And that realization carries an important message beyond Venus itself. When we imagine whether a distant world might be warm enough for oceans or cold enough for ice, astronomers no longer look only at how far it circles from its star. They also ask what kind of atmosphere surrounds it, how thick it may be, what gases fill it, and how those gases quietly influence every ray of sunlight that arrives. A planet's sky, it turns out, can shape its destiny just as profoundly as its orbit. Yet another mystery still remains. An atmosphere this powerful did not appear overnight. Something must have happened long ago, over countless millions of years. allowing Venus to slip further and further from the gentle balance that still protects Earth today. To understand that slow transformation, we have to travel backward into the distant past, to a time when Venus may have looked far more familiar than it does now, and when the path toward becoming a planetary furnace had only just begun. If you could travel backward through time, not by years or centuries, but by billions of years, Venus might not be the world you would expect. The thick clouds would not necessarily disappear, nor would mountains suddenly become green forests. The past is rarely so simple, but many scientists believe there may have been a time when Venus was far calmer than the world we see today. It is a fascinating possibility. The planet that now glows with unbearable heat may once have known something much closer to balance. Computer simulations developed over the past several years suggest that early Venus could have remained surprisingly moderate for an incredibly long time. If the right conditions existed, shallow oceans or large bodies of water may have rested upon its surface. Gentle rainfall might have fallen beneath skies very different from the ones we know today. Temperatures may have allowed liquid water to exist for millions, perhaps even billions of years. No one can say with complete certainty that this happened. The evidence is incomplete, and many questions remain unanswered. Yet the possibility alone changes the way we think about Venus. Instead of imagining a planet that was born as an inferno, we begin imagining a world that slowly became one. That single difference transforms the story from one about an unusual planet into one about change itself. Every world follows a journey. Some journeys lead toward stability. Others drift, almost imperceptibly, towards something entirely different. If early Venus truly possessed water, then those ancient oceans were doing far more than reflecting sunlight. On Earth, water quietly performs countless tasks that make our planet more comfortable than it might otherwise be. The oceans absorb warmth during the day. They slowly release that warmth later, softening the contrast between hot afternoons and cool nights. Clouds form, rain falls, rivers flow, evaporation and condensation repeat over and over, creating a graceful rhythm that helps stabilize the climate across enormous spans of time. Water is not simply something living creatures drink. It is one of the great architects of a planet's climate. Now imagine that balance beginning to shift. Perhaps the young sun slowly became brighter, as astronomers know it naturally does over time. Perhaps Venus simply received enough additional warmth that more water began to evaporate from its surface. At first, the change would have been almost impossible to notice. A little more evaporation, a little more moisture rising into the atmosphere. Nothing dramatic, nothing sudden. Yet nature often responds to small changes in surprising ways. Water vapor, the invisible form of water floating through the atmosphere, is itself remarkably good at holding warmth. On Earth, this is completely natural. It contributes quietly to the climate we experience every day. But on Venus, as more water entered the atmosphere, that invisible blanket may have grown just a little thicker. The slightly warmer planet produced more evaporation. The additional evaporation created more water vapor. The extra water vapor held on to even more warmth. That additional warmth encouraged still more evaporation. It became a gentle circle that slowly strengthened itself. Scientists describe this kind of process as a positive climate feedback. The phrase sounds technical, but the idea is beautifully simple. One change quietly encourages another, and together they begin moving in the same direction. Like a small snowball rolling down a hillside, each turn gathers just a little more snow than the one before. For a long time, the changes may have remained gradual. Millions of years could have passed with no clear moment when anyone, had there been an observer, could point and say, "Everything changed today." Instead, the planet slowly drifted away from equilibrium. As more water entered the upper atmosphere, another quiet process began unfolding, high above the clouds. Far above the weather, where sunlight arrives with tremendous energy. Invisible rays from the sun slowly pulled water molecules apart, each tiny molecule separated into hydrogen and oxygen. It happened silently, patiently, one molecule at a time. Scientists call this process photodissociation, but its name is far less important than its consequence. Hydrogen is the lightest element in the universe. Once freed from water, many hydrogen atoms drifted higher and higher until some escaped Venus entirely, disappearing forever into space. Oxygen remained behind. Some of it reacted with rocks upon the surface. Some escaped through other processes over immense stretches of time, but the water itself could never fully return. Every escaped hydrogen atom represented another tiny piece of an ancient ocean that would never come back. It is a strangely quiet image, not roaring seas vanishing overnight, not enormous waves boiling into the sky. Instead, a planet losing its water, one invisible atom at a time. Across hundreds of millions of years, those tiny losses accumulated into something extraordinary. The oceans, if they truly existed, gradually disappeared. Without abundant water, another important balance began weakening. Carbon dioxide, released naturally through volcanic activity, no longer had an efficient way to become locked away within oceans and rocks. Instead, more and more of it remained in the atmosphere. The invisible blanket grew thicker, the warming became stronger. The planet slipped further from the climate it may once have known. Eventually, Venus approached a threshold. Crossing that threshold may not have looked dramatic from space. There was no single explosion, no great flash of light, no cosmic disaster announcing itself across the solar system. Instead, the planet quietly entered a new state, a state from which returning became extraordinarily difficult. Scientists refer to this transformation as a runaway greenhouse effect. The phrase sounds sudden, but the reality is almost the opposite. It is the story of countless small changes, each one encouraging the next, until the planet reached a point where cooling itself became nearly impossible. From that moment onward, every remaining step carried Venus further toward the world we know today. The atmosphere thickened, the surface grew hotter, the ancient balance faded farther into the past. When we look at Venus now, we are not simply seeing a hot planet. We are seeing the final chapter of a story that may have unfolded over hundreds of millions, perhaps even billions of years. Its blazing surface is not the beginning of the mystery, it is the conclusion. And perhaps that is what makes Venus so captivating. It reminds us that the greatest transformations in nature are often not the fastest ones. Sometimes they happen so gradually that no single generation would notice them. Only time itself, patient beyond imagination, reveals how completely an entire world can change. Yet, even after understanding how Venus may have lost its oceans, another mystery quietly waits. If two neighboring planets began so similarly, why did Earth continue preserving its balance while Venus slowly lost its own? The answer lies deep within the remarkable systems that continue shaping our planet even today, often without us ever noticing they exist. By now, Venus has already revealed itself as a remarkable world. Its atmosphere traps extraordinary amounts of warmth. Its surface is hotter than any other rocky planet in our solar system. Its ancient history may include oceans that slowly disappeared over immense stretches of time. You might think we have finally begun to understand it. And yet, Venus still has more surprises waiting. Some of them have nothing to do with heat. Instead, they concern something far more fundamental: the way the entire planet moves. Here on Earth, sunrise feels wonderfully dependable. Morning arrives in the east, the sun slowly climbs into the sky. Hours later, it settles beneath the western horizon. It has happened for every human who has ever lived, so consistently that we rarely stop to think about it. On Venus, however, the sky would tell a very different story. If you could somehow survive on its surface long enough to watch the heavens, the sun would appear where you least expected. It would slowly rise in the west. Then, after an unimaginably long journey across the sky, it would finally disappear in the east. At first, that sounds almost impossible, yet it is simply the consequence of Venus turning in the opposite direction from almost every other major planet in our solar system. Scientists describe this as retrograde rotation, but the idea itself is wonderfully simple. Most planets spin one way. Venus quietly spins the other. Exactly why this happened remains one of planetary science's enduring mysteries. Some researchers think an enormous collision early in the solar system's history may have altered the young planet's rotation. Others suggest that countless millions of years of subtle gravitational forces, combined with the influence of its extraordinarily thick atmosphere, slowly changed the way Venus turned. Perhaps the answer includes both ideas. Perhaps it involves something no one has yet imagined. The universe often reminds us that even familiar worlds still have stories left untold. Its direction of rotation is only the beginning. Venus also rotates with astonishing slowness. Earth completes one full rotation in a single day. Venus takes about 243 Earth days to complete just one turn. Imagine waking up one morning and knowing that the same sunrise would still be unfolding many months later. It is almost beyond ordinary experience. Even more surprising, Venus finishes one complete journey around the Sun in about 225 Earth days. In other words, one day on Venus lasts longer than one entire year. It almost sounds like a riddle rather than a scientific observation. Time itself seems to behave differently there. Naturally, this raises another question. If one side of the planet faces the Sun for such an incredibly long time, shouldn't that side become much hotter while the opposite side grows colder? On many worlds, that expectation would be perfectly reasonable, but Venus quietly ignores it. The immense atmosphere surrounding the planet is constantly moving warmth from one region to another. Rather than allowing heat to remain where it first arrives, the atmosphere slowly redistributes it across nearly the entire globe. The result is extraordinary. The side facing the Sun remains astonishingly hot. The side facing away from the Sun remains astonishingly hot as well. Day and night become far more alike than our everyday experience would ever suggest. It is another reminder that on Venus, the atmosphere has become the dominant architect of the planet's environment. And then we encounter perhaps the strangest discovery of all. Although the solid planet turns incredibly slowly, the atmosphere above it races around the world with astonishing speed. Imagine standing beside a gently turning carousel. Now imagine the air above that carousel, circling dozens of times faster than the platform beneath it. It almost feels impossible. Yet something remarkably similar happens on Venus. While the planet itself takes many months to complete a single rotation, powerful winds high above the clouds can circle the entire planet in only a few Earth days. Scientists call this remarkable behavior superrotation. The name sounds dramatic, but it simply describes an atmosphere moving far faster than the world beneath it. Exactly why this happens remains one of the great puzzles of planetary science. Researchers believe several processes work together. Sunlight warms different layers of the atmosphere. Powerful waves move through the air. The planet's slow rotation may also influence the way momentum is transferred between different heights. Computer models reproduce parts of the phenomenon, but not every detail. Even today, no single explanation completely accounts for everything we observe. There is something wonderfully humbling about that. Venus is one of our nearest planetary neighbors. Spacecraft have visited it. Orbiters have photographed it. Landers have touched its surface. Powerful computers have modeled its atmosphere. And still, some of its most important behaviors remain only partly understood. Perhaps that is one of the greatest lessons of science. Learning more does not always shrink the mystery. Sometimes it simply reveals how much more there is to discover. The deeper scientists look, the more Venus becomes a world of subtle contradictions. It rotates slowly, yet its atmosphere races. It reflects enormous amounts of sunlight, yet remains the hottest planet. It resembles Earth in size, yet almost nothing else about its environment feels familiar. Every answer seems to uncover another question waiting quietly beneath it. That sense of mystery has inspired a new generation of exploration. Rather than viewing Venus as a world whose secrets have already been solved, scientists increasingly see it as a planet that still holds important clues about how rocky worlds evolve, its mountains, its volcanoes, its atmosphere, even the possibility that parts of its interior may still be geologically active. Each discovery has encouraged researchers to return with better instruments and new questions. After decades of studying Venus from afar, humanity is preparing to look again with fresh eyes. New spacecraft will once more descend through those brilliant clouds. Others will map the hidden surface with remarkable precision. Together, they may finally reveal details that earlier generations could only imagine. Because despite everything we have learned, Venus continues to whisper that its story is not yet complete, and perhaps the most remarkable chapters are still waiting to be uncovered. For thousands of years, Venus was simply a brilliant light in the sky. Even after telescopes became more powerful, its thick clouds refused to reveal what lay beneath them. Astronomers could measure its orbit, they could estimate its size, they could observe its dazzling brightness. But the surface itself remained hidden. It was rather like trying to understand an entire continent while seeing nothing more than an endless blanket of fog. Eventually, curiosity became stronger than distance. During the middle of the 20th century, humanity entered the space age. For the first time, scientists no longer had to rely entirely on observations from Earth. Machines could travel across the solar system, carrying cameras, instruments, and experiments directly to the planets themselves. Venus quickly became one of the earliest destinations. It also became one of the most unforgiving. Several early missions failed before they ever reached their destination. Some lost contact during the long journey through space. Others encountered technical problems before they could begin their scientific work. These setbacks were disappointing, but they also taught engineers an important lesson. Reaching Venus would require far more than simply building a spacecraft capable of crossing millions of kilometers. It would require building one capable of surviving another world entirely. The greatest breakthroughs came through the Soviet Union's remarkable Venera program. Mission after mission pushed a little further than the one before it. Some flew past Venus. Others entered orbit. Eventually, several spacecraft attempted something that had never been done before. They tried to land. Designing such a spacecraft demanded extraordinary engineering. Engineers knew the atmosphere would grow steadily hotter during the descent. They knew the pressure would become immense. Every electronic system had to be protected inside carefully insulated compartments. Every mechanical joint had to withstand forces unlike those experienced almost anywhere else. Even then, nobody expected these spacecraft to survive for very long after landing. The environment was simply too hostile. And yet, against remarkable odds, some of them succeeded. One by one, the Venera landers descended through the thick clouds, slowing beneath parachutes, before completing the final stage of their journey toward the hidden surface. For the first time in human history, instruments began sending measurements directly from the ground of Venus. The numbers confirmed what scientists had only begun to suspect. The atmosphere was overwhelmingly dense. The surface temperature remained above 460 degrees Celsius. The chemical composition of the atmosphere was dominated by carbon dioxide. The crushing pressure matched what engineers had feared. But perhaps the most unforgettable achievement was something beautifully simple. They took photographs. The images were unlike anything humanity had ever seen. Instead of oceans or forests, they revealed fields of fractured rocks, scattered across a broad landscape beneath an orange sky. The light appeared soft and muted. The horizon seemed strangely close because the dense atmosphere scattered sunlight in every direction. There were no signs of flowing water, no vegetation, no movement except the quiet presence of an ancient world resting beneath its enormous atmosphere. It was not a dramatic landscape. It was something even more remarkable. It was real. For only a brief time, those spacecraft continued transmitting information before the relentless heat finally overwhelmed their systems. Some survived little more than half an hour. Others continued operating for around an hour or slightly longer. Considering the environment surrounding them, those short lifetimes represented extraordinary achievements. They had accomplished exactly what they had been built to do. They had allowed humanity to stand, if only through machines, upon the surface of another planet. The exploration of Venus did not end there. Landing on the surface provided only isolated glimpses. Scientists wanted something much larger. They wanted to understand the entire planet. The greatest obstacle remained the same as it had always been: the clouds. Ordinary cameras could not see through them. Fortunately, nature offered another solution. Instead of using visible light, scientists turned to radar. Unlike ordinary light, radar waves can pass through the thick cloud layers and bounce back from the solid ground below. By carefully measuring those returning signals, spacecraft could gradually build detailed maps of landscapes that had remained hidden for centuries. One of the most important missions to accomplish this was Magellan, launched by the United States in the closing years of the 20th century. Orbit after orbit, Magellan patiently surveyed Venus. Slowly, an entirely new world emerged. Enormous volcanic plains stretched across much of the surface. Mountain ranges rose from the surrounding terrain. Immense circular structures hinted at powerful geological forces deep within the planet. Lava flows appeared to have reshaped vast regions over long periods of time. Instead of a quiet, inactive world, Venus appeared to possess a surprisingly dynamic geological history. That discovery raised another fascinating question. Could Venus still be changing today? For many years, scientists debated the answer. Some researchers believed the planet had become largely inactive, preserving landscapes that had formed hundreds of millions of years ago. Others suspected that volcanic activity might still continue beneath the surface. More recent observations have made that possibility increasingly intriguing. Several orbiting spacecraft have detected changes that may be consistent with active volcanism. In one region, scientists observed features that appeared to change shape over time, resembling the collapse of part of a volcanic vent after fresh lava had emerged. Other observations have detected temporary increases in gases that could be associated with volcanic eruptions. None of these findings alone provides absolute proof. Science rarely reaches conclusions from a single observation. Instead, confidence grows gradually as multiple pieces of evidence begin supporting the same explanation. For now, many planetary scientists consider active volcanism on Venus to be a genuine possibility, although important questions remain. If volcanoes are still erupting today, they may help explain how the atmosphere continues evolving even now. That possibility has renewed excitement throughout the scientific community. After decades in which Mars received much of the world's attention, Venus has once again become one of the most anticipated destinations for planetary exploration. Several new missions are now preparing to continue the journey begun by the pioneers of the space age. The Da Vinci mission plans to descend through the atmosphere, making precise measurements of its composition, while searching for clues about the planet's ancient history. The Veritas mission is designed to create remarkably detailed maps of the surface, allowing scientists to search for evidence of recent geological activity and better understand the planet's interior. Meanwhile, the European Space Agency is preparing the Envision mission, which will examine Venus from orbit using a new generation of scientific instruments, studying the atmosphere, the surface, and the hidden processes that connect them. Together, these missions represent something more than technological progress. They represent patience. Each generation of scientists builds upon the work of those who came before. Each mission answers a few questions while uncovering many more. Venus has never stopped surprising us. The closer we look, the more complex its story becomes. And perhaps that is why this neighboring world continues to hold such a special place in planetary science. It reminds us that, even after decades of exploration, some of the greatest discoveries are not the ones we have already made. They are the ones still waiting quietly beneath those brilliant clouds, ready for the next visitor to arrive. After spending so much time exploring Venus, it is natural to find your thoughts drifting back toward home. The comparison almost invites itself. Two neighboring planets, nearly the same size, born from much of the same material more than 4.5 billion years ago. Yet today, one is covered with oceans, forests, clouds of water, and countless forms of life. The other rests beneath an atmosphere so dense and so hot that even the most carefully engineered spacecraft can survive there only briefly. What separated their destinies? The answer is not a single event. It is a collection of quiet processes that have been working together on Earth for billions of years. Most of them happen so slowly that an individual human life is far too short to notice them. Imagine placing a saucepan of water on a stove. As the flame grows warmer, the water absorbs heat gradually. It does not become boiling hot the instant the stove is turned on. Water has an extraordinary ability to store heat, releasing it only slowly over time. Earth's oceans behave in much the same way. Every day, they absorb enormous amounts of energy from the sun. Rather than allowing the land to heat and cool dramatically, the oceans gently smooth many of those changes. Coastal regions often experience milder temperatures than inland deserts, because the nearby sea quietly stores warmth during one season and releases it during another. The oceans are not simply places where life exists. They help regulate the planet itself. Above those oceans, another remarkable cycle repeats endlessly. Water evaporates, clouds form, rain falls, rivers carry water back toward the sea. The process never truly ends. Each step redistributes heat, while also moving enormous quantities of water around the globe. Without this continuous circulation, Earth's climate would feel profoundly different. Yet perhaps the most important process is one that almost nobody ever sees. It happens beneath your feet. When rainwater falls through the atmosphere, it absorbs a small amount of carbon dioxide from the air. As that water moves across rocks and soils, slow chemical reactions gradually lock some of that carbon into minerals. Rivers eventually carry many of these dissolved materials toward the oceans, where they can become part of sediments resting on the seafloor. The process is extraordinarily slow, not years, not centuries, often millions of years. But time is one resource that planets possess in abundance. Scientists refer to this collection of processes as the carbon silicate cycle. The name may sound technical, but its purpose is beautifully simple. It acts like a natural thermostat. When Earth becomes warmer over long periods, weathering tends to increase. More carbon dioxide is gradually removed from the atmosphere and stored within rocks. When the planet becomes cooler, weathering slows, allowing volcanic activity to replace some of that atmospheric carbon dioxide over immense spans of time. Neither process happens quickly, neither responds from one season to the next. Instead, together, they help prevent Earth's climate from drifting too far in either direction over geological history. Another quiet partner works alongside this cycle: plate tectonics. If you could watch Earth from far above for hundreds of millions of years, the continents would slowly wander across the surface like enormous floating rafts. Mountains would rise, oceans would open and close, entire coastlines would disappear, while new ones emerged. These movements are almost unimaginably slow, yet they constantly recycle parts of Earth's outer shell. Some rocks carrying stored carbon are eventually pulled deep into the planet. Volcanoes later return part of that carbon to the atmosphere. It is an endless exchange between the sky, the oceans, the crust, and the deep interior. Venus appears to have followed a different path. Unlike Earth, there is no clear evidence that Venus possesses an active system of plate tectonics, like the one shaping our own planet today. Without that global recycling system, carbon dioxide released by volcanic activity may have accumulated in the atmosphere over immense spans of time, rather than becoming locked away as efficiently within the crust. The loss of abundant surface water would have made that imbalance even greater. Little by little, the atmosphere grew thicker. The greenhouse effect strengthened. The surface became hotter. The two neighboring worlds slowly drifted farther apart. When viewed over billions of years, the difference is astonishing. Earth remained a planet where water, rocks, air, and the deep interior continually interact. Venus became a planet where many of those balancing processes appear to have weakened or disappeared. It is rather like two clocks that began ticking at exactly the same moment. One continued adjusting itself whenever it drifted slightly out of rhythm. The other gradually lost that ability, allowing every small change to accumulate until the entire system followed a very different course. This comparison naturally raises a question that many people wonder about. If Venus experienced a runaway greenhouse effect, could the same thing happen to Earth? It is an understandable concern. The two planets are often described as twins, and the dramatic story of Venus can sound unsettling when viewed through the lens of our own changing climate. Here, it is important to make a careful distinction. Current scientific understanding does not indicate that modern human-caused climate change is expected to transform Earth into another Venus. The conditions that produced Venus's runaway greenhouse effect involved an entirely different planetary history, including its closer orbit to the Sun, the probable long-term loss of surface water, and billions of years of atmospheric evolution under circumstances very different from those on Earth. This does not mean that climate change on Earth is unimportant. Far from it. Human activities are altering Earth's climate in measurable ways, affecting temperatures, weather patterns, oceans, ice sheets, and ecosystems across the globe. These changes are significant and deserve careful scientific attention, but they are not expected to trigger the same runaway greenhouse process that produced the modern Venus. Understanding that distinction helps us appreciate both planets more clearly. Venus is not a prediction of Earth's future. It is a natural laboratory. It allows scientists to study how planetary climates can evolve under very different conditions, improving our understanding not only of our own world, but also of countless rocky planets orbiting distant stars. The story of Venus is therefore not one of fear, it is one of perspective. By comparing two neighboring worlds that began so similarly, we gain a deeper appreciation for the delicate balance that continues to shape Earth every single day. And as astronomers now discover thousands of planets circling distant suns, the lessons learned from Earth and Venus have become more valuable than ever before, guiding our search for worlds that might also find their own quiet balance somewhere among the stars. As our journey slowly draws toward its end, it is worth returning to a simple question. Why do scientists continue studying Venus so carefully? After all, it is not a world where future cities are likely to rise beneath open skies. It offers no flowing rivers to explore, no forests waiting to be discovered, and no familiar landscapes where human explorers might one day walk without extraordinary protection. At first glance, it might seem like a planet whose story has already been written, yet the opposite is true. Venus has become one of the most important teachers in all of planetary science. Every new discovery made there helps us understand not only our own solar system, but countless other worlds scattered across our galaxy. Only a few decades ago, astronomers knew of just the planets orbiting our own sun. Today, the picture has changed dramatically. Powerful telescopes have revealed thousands of planets circling distant stars. Some are enormous worlds larger than Jupiter. Others are small rocky planets not very different in size from Earth or Venus. Each discovery raises the same quiet question: could life exist there? At first, the answer appeared wonderfully straightforward. Scientists searched for planets located at just the right distance from their stars, where temperatures might allow liquid water to remain on the surface. This region became known as the habitable zone. It was an excellent beginning, but Venus taught astronomers that distance alone is never enough. Imagine two houses built on the same street. Both receive nearly the same amount of sunlight every day. From the outside, they appear almost identical, yet one has wide-open windows allowing fresh air to circulate, while the other has every door and window tightly sealed beneath thick insulation. Even though both stand beneath the same sun, the temperature inside each house can become completely different. Planets behave in much the same way. Their distance from a star matters greatly, but so do their atmospheres. The thickness of the air, its chemical composition, the presence of oceans, clouds, geological activity, even the slow movement of rocks deep beneath the surface. All of these quiet processes shape the long story of a planet. Venus transformed the way scientists think about habitability. Rather than asking only, how far is this planet from its star, astronomers now ask many additional questions. Does it possess an atmosphere? How dense is that atmosphere? What gases dominate it? Could liquid water survive there? Is the surface still geologically active? Does the planet recycle carbon through long-term geological processes? Each answer brings researchers a little closer to understanding whether a distant world may remain stable over billions of years. In many ways, Earth and Venus have become the two reference books against which countless newly discovered planets are compared. One demonstrates how a rocky planet can maintain conditions suitable for liquid water and abundant life. The other reveals how a similar world can slowly evolve into something profoundly different. Every newly discovered rocky planet may lie somewhere between those two stories. That is one reason the next generation of Venus missions is so exciting. The Da Vinci mission hopes to descend once again through the atmosphere, measuring gases with remarkable precision as it approaches the surface. Tiny differences in atmospheric chemistry may preserve clues about whether ancient oceans truly existed and how the planet changed over time. The Veritas mission plans to create some of the most detailed maps ever made of Venus, revealing subtle geological features that earlier spacecraft could not resolve. Scientists hope these observations will help determine whether volcanoes are still reshaping parts of the planet today. Meanwhile, the European Space Agency's Envision mission will study the planet as a complete system, examining how the atmosphere, the surface, and the interior continue interacting even now. Each mission asks new questions. None expects to solve every mystery. That has always been the rhythm of science. Every answer becomes the beginning of another journey. There is something quietly comforting about that idea. Human knowledge does not advance in sudden leaps very often. More often, it grows patiently. One observation, one experiment, one spacecraft, one generation building gently upon the work of another. Venus reminds us that understanding an entire world requires extraordinary patience. Its story unfolded across billions of years. Learning that story also takes time. Perhaps that is why this neighboring planet feels so different now than it did at the beginning of our journey. When we first looked toward Venus, we saw a brilliant light shining peacefully in the evening sky. Now that same light carries another meaning. It has become a reminder that appearances can be wonderfully incomplete. Beneath calm clouds may rest extraordinary histories. Beneath familiar similarities may lie entirely different destinies. And beneath every answer waits another question. inviting us to continue looking with curiosity rather than certainty. Perhaps the greatest lesson Venus offers is not about heat, nor about clouds, nor even about planetary atmospheres. It is about balance. Worlds are shaped by countless small processes, working together across spans of time, almost too vast to imagine. A little more warmth, a little less water, a slightly different atmosphere, a different geological history. Over millions and billions of years, those quiet differences become entirely different planets. As you think about Earth tonight, perhaps it feels just a little more extraordinary than it did before. Not because it is perfect, but because it is rare. The familiar blue oceans, the drifting white clouds, the gentle rhythm of rainfall, the changing seasons, the cool evenings after warm afternoons. These ordinary experiences are part of a remarkably delicate planetary story, one that has unfolded continuously for billions of years. Seen from far away, Earth and Venus might still appear like close relatives traveling together around the Sun. Only when we look carefully do we discover how differently their journeys unfolded, and perhaps that realization leaves us with a quiet sense of wonder. The universe is filled with worlds, some frozen, some scorching, some wrapped in endless storms, others still waiting to be discovered. Each carries its own history, written not in words, but in mountains, atmospheres, oceans, and time itself. Tonight, we have spent our journey beside one of the brightest lights in our sky, a world that once seemed familiar, then mysterious, and finally profoundly different. Its story reminds us that science is not simply a collection of facts. It is an invitation to keep wondering. And now, as the evening grows quieter and your thoughts become a little slower, you might imagine Venus once more, shining softly near the horizon, just as it has for countless generations before us. Its brilliant clouds still hide many secrets. Its ancient landscape still waits beneath that luminous veil. And somewhere, perhaps years from now, another spacecraft will descend through those silent layers of cloud, carrying with it humanity's endless curiosity, continuing a story that is still being written. Until then, Venus will remain what it has always been: a beautiful light in the sky, a remarkable world next door, and a gentle reminder that even our closest neighbors can still surprise us. Thank you for sharing this quiet journey through one of the solar system's most extraordinary planets. As you settle more comfortably into the stillness of the night, perhaps you can picture Earth and Venus moving together around the Sun, each following its own ancient path through the darkness of space. One became a world filled with oceans, forests, and countless forms of life. The other became a world wrapped in brilliant clouds, preserving the memory of a very different destiny. Both have something important to teach us. One reminds us how life can flourish when countless natural systems remain in delicate balance. The other reminds us how patiently a planet can change when that balance is slowly lost. Above all, they remind us that the universe is far richer, more subtle, and more beautiful than it first appears. And perhaps that quiet sense of wonder is the most comforting companion we can carry into sleep. Good night, and may your dreams be as peaceful as the distant stars that continue shining above us all.